All right, learners, welcome back to our channel. If you are coming for the first time, don't forget to subscribe to our uh, channel and be part of this family. Now, in this one, it's electric circuits. The circuit diagram below shows the four resistors connected to a battery of EMF and internal resistance R. The resistance of the ammeter and the connecting wires are negligible, and while the voltmeters have very high resistance. So you can pause the video and try it, and then after that you play, then we continue together. Now, we are going to answer these questions together. 8.1, state Ohm's law in words. It says that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So you must define it according to the CAPS, or rather the examination guideline. Now let's answer 8.2. And then 8.2.1, switch S is closed. The reading on the ammeter is 3.5 ampere. And the question is calculate the total external resistance of the circuit. All right. So what is series? Current have one path to flow. What is parallel? Current have more than one path to flow. You look at that. So if you check 3 and 2, they are in series. But the sum of 3 and 2 are in parallel with 1. And then the answer is in series with 4. So which means the first thing that you're going to do, you will say R series. You add 3 plus 2 to give you 5 ohm. Okay. And then now you go to R parallel. R parallel 1 over 5. This 5 which we have here, this one. Plus, then it will be 1 over 1. And then after solving the parallel, you can use a calculator, then you're going to win. So you're going to get 0.83. Let's press ohm. Okay. Then the R total, what do we have? We're going to have 0.83 plus which one? Plus 4. So the answer is going to be 4.83 ohm. That is the answer for this one. Don't make a mistake. That is very easy. Now, 8.2.2. Calculate the reading on V1. Calculate the reading on V1. What are you going to do? Obviously, you're going to use the Ohm's law. R is equal to V over I. And then we are looking for V. The reading on V1. Where is V1? Obvious is the potential difference across the what? The entire circuit. What is R? We are going to have is 4.83 is equal to V. What is I is for the whole circuit. The entire circuit is 3.5. So what is V1 actually? V1, you can see it's here. You see? Across the resistor. And then you multiply, what are you going to get? 16.91 volts. These are very good marks. How does the reading on V2 compare to the reading on V1? Choose smaller than, equal to, or greater than. Where is V2? Remember V2, obvious, it's for those particular resistance. It's only for 3 and 2. So meaning that the answer is smaller than. Because V1 is for the entire circuit. It should be greater than V2. Okay. Now the next one, 8.3.1. The question is saying, define the term EMF. What is EMF? Maximum work done by the battery per unit charge. Don't forget that. Is maximum work done by the battery per unit charge. You can use examination guideline. Now remember, Elena concludes that the EMF of the battery is equal to the reading on V1. Okay. The question is the learner's conclusion correct? No, that is no. Okay. The answer is no. Why it's no? The battery has internal resistance. The reason is there is internal resistance, because some of energy is lost. That's why they are not the same. All right, till we meet on the next video.